Good day, everybody, and welcome to another video with James McManus. We are going to be dealing today with an algebra section known as inequalities. We're going to be dealing with the basic linear, quadratic, and rational inequalities. Linear is more grade 8, 9, and 10 level, where we kind of learn how to represent stuff on a number line, and for quadratic and rational is more for grade 11, grade 12 level. Okay, so I'm going to do an example of each one, and we're not going to be doing complex procedures. We're just going to handle the basics for now. How do we represent this on a number line, how we do the algebra, and then we're going to go from there. Okay, so we're going to start off with an linear inequality. And the equation that we are going to use is 2x plus 4 over 7 is greater than or equal to 3 open bracket x minus 3 everything over 3. Now, very important, guys. We must understand that inequalities is not just working out one or two specific values of x. It's working out a domain of x values that would satisfy the following inequality. So we're going to get a bunch of x answers, but we're going to represent it in either set builder notation or interval notation. I'll go into the types a little bit further on in the video. So the first thing that we're going to do is we're going to treat it as if it's a normal equation, and we're going to LCD this. So we're going to say our LCD here is going to be 21, which means I must then times this by, let's use red because linears are going to be red. So we're going to times this by 3, times this by 3, times this by 7, times this by 7. So what's going to happen here is we're going to have 3 open bracket 2x plus 4 is greater than or equal to 7 times 3, which is 21, and we still need to times that 21 into the x minus 3 bracket. We're then going to distribute the 3, so we're going to have 6x plus 12 is greater than or equal to, distributing the 21x minus 63. We can then take all the x's over to the left, so we're going to have minus 15x is greater than minus 63 minus 12, which is going to be minus 75. Okay, you can see I'm doing a lot of quick algebra here, guys, because this isn't an algebra video. This is more explaining inequalities. If you want to obviously learn how I did that quite quickly, you can look at the other videos with regards to algebra and how to simplify equations. And as you could see as well, I've treated this as if it was an equation up until this point. The reason why I've stopped here is because when you divide by a negative with inequalities, what happens, everyone? When you divide by a negative, obviously I'm trying to get x by itself. So I'm going to divide this side by minus 15, divide this side by minus 15. Those are going to cancel. That's going to go in 3 times. But what happens is that the inequality then switches direction. So when you divide by a negative, your inequality sign switches direction. Okay, so now what we're going to be doing is we're going to be doing x is less than or equal to 3. Therefore, if I had to represent this on a number line, I would draw a line. I would put my critical value of 3 down. Closed dots in inequalities means it can also equal that number, which means that it can also equal 3. And what am I looking for to represent? I'm looking to represent all the x values that are smaller than or less than 3. X values that are smaller than or equal to 3, which would be to the left or to the right of this dot. It would be to the left because all the values less than 3 would be to the left of this number line. And that's how we would have done a linear inequality. That is our final answer being represented on a number line. Does everyone understand? Fantastic. Okay, so the next inequality we're going to be dealing with, let me just make this a little bit neater. The next inequality that we are going to be dealing with is the quadratic inequality. Okay, so quadratic inequalities. Okay, so what's the difference? Linear meaning your highest power of x will be a 1. Okay, and then with quadratic, it is your highest power of x is going to be a 2. Also, more specifically, it'll 9 times out of 10 be in the form of a parabola. Okay, so let's get an example going here. X, open bracket, x minus 4 all over 3 is less than x minus 4. Okay, so again, treat it exactly the same way as the linear. We treat it as if it's an equation, and we LCD this. Okay, so our LCD here is 3. So we put this over 1. We times this by 3 times this by 3. Therefore, we have x, open bracket, x minus 4 is less than 3, open bracket, x minus 4, close bracket. We can times everything in, so x squared minus 4x is less than 3x minus 12. We can then bring everything, and that's the difference between a linear and a quadratic inequality, guys, is that the other one, we kind of isolate the x on one side and numbers on the other, whereas this one, when we have the squared, we need to bring everything over to the left and make the whole inequality less than, greater than, or equal to 0. So we're going to bring it over, x squared, that's going to become minus 7x, and that's going to be positive 12 is less than 0. Great. Now we have a trinomial, which we can then factorize. Okay, so I know a lot of calculators do it nowadays, but there's nothing wrong with having the technique that we have. So factors of 12, that's going to give me a 7 when I add or minus it together. There will be a video on this with regards to trinomial factorizing. So if you guys aren't familiar with that and you don't use your calculator, it would be a good idea to go and revert on that video just to get your trinomial factorizing in place. Trinomial factorizing does pop up again in trigonometry, and a lot of people struggle with that because you can't put the trig functions into your calculator when doing your factors and so on and so forth. So it's not a bad idea to get your trinomial factorizing up to scratch. So we've got x and x here. Factors of 12, that's going to give me 7 is going to be minus 3 minus 4. Okay, great. So now obviously if this was an equation at this point in time, we would say x minus 4 equals 0 or x minus 3 equals 0, and then get x is equal to 4 and x is equal to 3. We in a sense are doing that, but what we want to do is we want to rather call them critical values, because the critical values is what's going to end up on my number line. So if I had made these equal to 0 separately, I would have got x is equal to 3 and x is equal to 4. And what I would do from there is then I would draw my number line. And then I would put my critical values there, okay? I'm going to put open dots. The reason why they're open dots is because they cannot equal 0, okay? There's no equal to sign underneath my less than sign, therefore I have to have open dots. If this was an equal to sign here, these would then be closed dots, because then they would be allowed to be equal to the critical values. We're then going to say to ourselves, okay, we're going to use the parabola method here. So I'm going to draw a parabola and a happy face parabola. Why am I drawing a happy face parabola? Because my a value of this parabola is a positive, isn't it? So that means that I have a happy face parabola going here. So that is my a value, which is positive. Now, do you agree with me that the y values of this parabola, everything to the left of 3, my y values are positive, and everything to the right of 4, my y values are positive. And then everything below the x-axis is considered to be negative y values. So everything in between 3 and 4 is negative. Now, once my parabola is finished and my regions have been established, we then look at the question. We're looking for where this parabola is less than 0. Guys, anything less than 0 is considered to be negative. So we would be looking for this region here. Okay. So the region that we are going to state as our answer is going to be x must be greater than 3, but it must be less than 4. Okay, fantastic. So what I'm going to do, we'll do another version. Say, for example, let's carry on here. Let's say, for example, my factors or my brackets were like this, and we had a greater than or equal to. I'm just giving you a bit of more scenarios here. So say, for example, it's a completely different question, and that's what I have. So I'm dealing with a happy face parabola again. My critical values still remain 3 and 4. Okay, I'm going to draw my number line. I'm going to put my 3 and my 4 here, and I'm going to have closed dots according to this question, right? So just bear in mind, I'm doing a completely new question to the one above, just to show you the different scenarios of when different regions are my answers. So here I've got, okay, so it's going to be a happy face parabola, very similar to the last question. Everything that I'm doing now is exactly what I've done in the previous question. Okay, the only difference is that it's closed dots because it's an equal to sign under my greater than sign. And then here it is negative. So we've got the positive, and we have the negative. Now this question's asking me, where is this parabola greater than or equal to 0. So anything considered to be greater than 0, guys, is considered to be positive. So it means that I would be going that way and that way. Those are the regions that I need to state as my answers in order to satisfy this equation. So I'm going to say that x must be greater than or equal to 3, or x must be greater than or equal to 4. Okay, now on top of this, I just want to kind of, okay, we'll go through it once we're done with the rational one. Okay, so that's a quadratic inequality, everybody. Okay, and that's the two different versions that you can get from that as well. Now we're going to move on to the rational inequality. Okay, so the rational inequality is a little bit different. Each one is different, actually. So let's give it x minus 3 is greater than 4 over x. Okay, cool. So what we would do first, again, we would, okay, very important. When there's variables in your denominator, you have to bring everything over to the left-hand side. So we're going to bring everything over to the left-hand side, okay? Cool. And we're going to put everything over 1, and we're going to LCD it. My LCD is x. Okay? So normally, yes, we would have restrictions at this point, right? We can say that x cannot equal 0. Why can x not equal 0? Because x is in the denominator, everybody. And if x is 0 and it's in the denominator, it would make your whole equation undefined. So we need to put a restriction in there. Okay, and I'm just going to heading that restriction. Okay, so now LCD is x. So let's go ahead. Let's times this by x times this by x. So we've got x, open bracket, x minus 3 minus 4 greater than 0. Notice how my LCD is not falling away. Okay, so that's the difference. In inequalities, we can't just get rid of our LCD after we've applied it. We have to keep it there because that is also going to act as one of our critical values on our number line. So we've now got x squared minus 3x minus 4 all over x is greater than 0. We can then factorize this using trinomial factorizing. So we're going to say x, and we're going to go minus 4 plus 1. Okay, now have a look at this, guys. We are now going to state that our critical values is now going to be everything at the top and everything at the bottom. So 0, minus 1, and 4. Those are my critical values for this question. We take the top and the bottom of the fraction into consideration when working out our critical values. We then draw our number line, and we know minus 1 comes first, then 0, then 4. Okay, so now we've got 3 critical values here, guys. We can't draw a graph like in quadratic inequalities and work out our regions. We have to physically sub in values into this and then get the regions. So watch this. My first substitution for my first region, let's call it region 1, region 2, region 3, and region 4. So my first substitution, I can sub in anything to the left of minus 1. So let's sub in minus 2. Minus 2 plus 1 minus 2 minus 4 all over minus 2. Okay, so what's this going to give me? If I times this and this together, that's going to give me minus 2 plus 1 is a minus times a minus. This whole result at the top is going to give me a plus, and then I've got a minus at the bottom. So what is my final answer here? This is going to be a minus. Okay, so that's going to be a minus region. Now I'm going to do my second region. My second region, I can sub in anything between minus 1 and 0. So let's sub in minus a half. So minus a half plus 1, minus a half minus 4, all over minus a half. Notice how I'm not worrying about the actual value of the fraction. I'm just worrying about the sign because that's what I'm looking for. So that's going to be a minus. So minus a half plus 1 is going to be a positive. Okay, so this is going to be a plus. This is going to be a minus, and this is going to be a minus. So these times together gives me a minus. Minus over a minus is a plus. Okay, so this is a positive region. Cool, let's look at region 3. So we're going to look at region 3 and we're going to say, okay, we've got anything in between 0 and 4. So let's put 1. 1 plus 1, 1 minus 4, all over 1. Okay, so we've got a minus here, and we have a positive and a positive. Minus over a positive equals a minus. Okay, so we're going to have a minus here. And then the next one is my region 4. So let's have a look. We're going to sub in a 5, so 5 plus 1, 5 minus 4, all over 5. That is going to just be plus, 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 and that is equal to a positive. Okay, so that's how you figure out your regions, okay? Now, a lot of people ask me, James, can you assume it's going to be plus, minus, or minus, plus, minus, plus? No, you can't, okay? So sometimes it will be a bit different, and you have to do the substitutions in order to get it, okay? Can't assume that it's just going to be alternating every single time. So now this question is asking me, guys, where is this function greater than 0? So anything greater than 0 is the positive regions. I also haven't put my dots here. So I need to put my dots. So there's going to be open dots. You with me? So we're looking for the positive regions. So that's one of them, and that's one of them. So my answer here is going to be x must be greater than minus 1, but less than 0, or x must be greater than 4. Okay, and that is a rational inequality. Okay, now I've done everything in set builder notation. And there's also something called interval notation, and I'm going to do that in blue quickly just to show you how to represent both. So what I've done is set builder notation, and now interval notation is as follows. So for this one, you would say that x is an element of, so x is less than or equal to 3, right? So x is less than or equal to 3. So x is an element of negative infinity to 3 hard brackets. Okay, so the hard bracket represents also equal to, whereas a soft bracket represents not equal to. Okay, so everything to the left of 3 is what I'm dealing with. So I'm going all the way as far as negative infinity to 3 and representing it in interval notation. Okay, these two over here, how we would represent this, we would say x is an element of, so x must be, oh, I've made a mistake here. This should be less than, isn't it? There we go. So x must be less than or equal to 3. So that means that we should state that it should be from negative infinity to 3, close square bracket, or union is the sign for the or in inequality or in interval notation. We're going to say equal to 4 to positive infinity. Okay, and that's how we represent that one. Then the next one, we're going to state x is an element of, can't equal minus 1 to 0, can't equal union, can't equal 4 to positive infinity, can't equal. Okay, so those are the interval notation versions of your answers if you prefer to do it like that. Okay, so fantastic, everybody. That is a inequality video on the different types of inequalities that you get in algebra. Hope you enjoyed it. All these notes are also in something called the James book, which I am selling. So if you are interested, please drop me a WhatsApp, drop me a message, or even comment on the video requesting one, and we can make it available to you. And then, yeah, I look forward to, or click subscribe as well if you like this video and you want to see more. And we look forward to seeing you in the future. Awesome. Have a good one.